go. All right, guys. So our final is tomorrow. Now, I do want to offer this to you guys. If we finish our practice final today, which we will, I'm saying if we finish it maybe before lunch, if you're just feeling in the zone and ready to go and want to knock it out today, take your final, you guys are absolutely welcome to. You don't have to. That's no pressure there. You can wait till tomorrow, but if you want to do it while it's fresh in your brain, absolutely. I'm going to give you that opportunity. Awesome. All right, let's go ahead and get started. So on the first page, we are throwing it back to functions. You guys remember those? Yeah. So the first thing we're going to do on these first two questions are we're going to identify the domain and the range of the following relations, and then we're going to determine whether or not the relations are functions. So first of all, which values are included in the domain? Yes, our x values. So I'm going to write that above here as a key. And remember these brackets. X values. And our range is which ones?
Y.
The y values. Good. And I put them in red and blue as a little reminder, because we always use red for x and blue for y. So now that we know that, let's figure out our domain. Maybe we should label our x's and y's first. You guys want to do that? Let's label. So here's x in the first spot, and our y's are in the second spot of a coordinate. Okay, so now that we've got them labeled, what's the first thing we need to write for our domain?
A bracket.
A bracket. Please do not forget to put your domain in brackets and your range. Yeah, I got to do that part first. Now that we've got our outer bracket on the first side here, what are our values for domain?
-5, 4, 10, and 12.
Perfect. -5, 4, 10, 12. And then we put another bracket on the outside to close it. Okay, same thing for range. Start with a bracket. And what values am I going to put for range?
-6, -7, 9, and 8.
Perfect. Perfect. Okay, so we've got our domain and range. Is the relation a function? Do you guys remember how to tell if it's a function?
Because they each have a partner.
Yes, every x has to have exactly one y. So if any x's have more than one y, it's not a function. So is this a function?
Yes.
Yes, it is. Okay, let's look at number 2. Let's start by labeling our x's and our y's. I think that's always a good place to start. So we've got our x values first, and our y's come second. And what's our domain gonna be?
-4,
Mm-hmm.
7, or say 1.
Uh-huh.
1 and 3.
Good. -4, 1, there's another -4, so we don't have to write that again. And 3. Perfect. That's it for the domain. How about the range?
2,
Mm-hmm.
7, 9, and 5.
Perfect. 2, 7, 9, 5. Is this relation a function? No, why not? Yeah, we've got a repeating x here. We've got a -4 that goes with a 2. We got -4 again, but this time it goes with 9. So x, -4, has more than one y value. So this is not a function. Good. Do you guys want a refresher on how we can check if something's a function in case we forget or are unsure?
I remember the three was choosing next to each other.
Yeah, we can create that x and y chart. So here, I'll show you real quick. you would just write your -4, your 1, and your 3. And I see -4 goes with 2, 1 goes with 7, 3 goes with 5. My other -4 goes with 9. And you could see right here, my -4 has 2 y's. So it's not a function because of that. Okay, any other questions at all on numbers 1 and 2?
No, we rock it.
Y'all rock it. Okay, let's look at 3. Number 3 is something that we haven't explicitly done. Like, I haven't ever given you a table and said solve for all the y values. However, we have done this process before. So I want you to solve for y, there's my y, to complete the table. So I have given you 6 different values for x. So all you need to do is put x into this equation and figure out that whenever x is 12, for example, what is y?
Oh, okay.
Yeah.
So do the equation for each one.
Yeah, so let's go ahead and start. We're going to write a little small or get a scrap piece of paper. Yes, if you need scrap paper for this one, absolutely you can. I already worked this out last night. You can make it fit on here, but it's a little tight. So if you want scrap paper, go right ahead.
Get all my notes together here. All right.
And once you guys are ready, we'll go ahead and get started with
Just
this.
gonna label these numbers.
How are you labeling your numbers, Star? I'm
I
curious.
just put on the side here 1 through 6.
1 through 6. So
I
you can label your work?
Yeah.
That is smart. I'm going to do the same thing, actually. 1, 2, 3. And you guys don't have to do this. 4, 5, 6. But it does help you stay a little organized so that you remember where to put your answer.
Yeah.
Because, you know, it's easy to forget. So I'm going to write number 1 and circle it so I know that right now I am going to be looking at my first problem. So what would I write to begin this problem?
I always put the problem itself, but it's already there.
Yeah.
So it would be y equals 1/2, and then in brackets you would put 12.
12.
Right?
Good.
Plus 2.
Plus 2. Okay. So now we just need to solve this. 1/2 times 12. This is the same thing really as 12 divided by 2. Do you guys see how that's possible?
Yes. As soon as I did that, I realized that.
Yeah, that'll just it'll save you a little time typing things in. You can also still do 1/2 times 12. But what is 1/2 times 12 or 12 divided by 2? Good. So I'm going to rewrite this. Y equals 6 plus 2. And what does y equal when x is 12? 8. So there is my first answer for number 1. So I'm going to write 8 in the y spot of that chart. Now let's do number 2. So I'm going to do the same thing. I'm going to write y equals 1/2 times 14 this time, plus 2. Good. So that means y equals 7 plus 2, y equals 9. So we'll put 9 next to 14. All right, you guys to that point? I don't want to go too fast. All right, we ready for the third one? How about this? I'm going to let you guys try and work out the rest of them. And I'm going to work them out silently up here so you can look up and check your work. I want to see that you guys can do that on your own because I think you can. So I'm going to just silently work it out up here. And feel free to shout any questions that you have. And you might start to notice a pattern with your y's. You might not have to solve all of them. Ah. You'll probably notice the pattern by the third one. Okay, you guys take your time, but I've got mine filled out if you want to check any of your answers. Got that up here for you guys. Once everybody's finished, I want to talk to you guys about the pattern that we might notice. Alright, you guys getting close to being finished? What number are y'all on?
I'm done.
You're done? Perfect.
I messed up, I have to redo mine.
That's okay.
Oh, hush, like I heard you. Yeah, I heard you.
Here, I'll pause this so you guys take. Okay, your answers look like mine? What pattern did you guys notice?
Yes, X goes up by 2, Y goes up by 1.
Yes, every time I increase X by 2, I increase Y by 1. That's also like our rise over run. You see that? We go up 1 in the Y, we go over 2 in the X. Rise is 1, run is 2. So if you really wanted to save yourself all this work, you could just figure out the solution for the first Y. Hey Candy, how are you? Good, good. Hang on, I'm gonna pause this. All right, so like we were saying, what we could just do is solve for our first Y, and we could use that slope. We just go up 1 Y every time when we go over 2 for X. You see that?
I see that.
Because we've got 1 over 2, rise over run. Yeah, yeah. Okay, any more questions about the first page? Okay, awesome. Let's go ahead to the second page, and Candy, I'll let you see all these after we're done. All right, second page. We've got some graphing problems here. On number 4, I'm going to have you graph the line of this linear equation here. So first of all, what form is this equation in?
ABC.
Yes, it's in our standard form, or that AX plus BY equals C. So if we want to graph an equation that's in standard form, how can we figure out the things that we need? We just need a slope and a y-intercept, right? We need those 2 points to be able to make our line. So how do we find those?
For slope, you would do negative A over B.
Yes, our slope is negative A over B. And what is our y-intercept?
C over B.
Yeah, it's going to be C over B. And real quick, I'm going to run you through how we came up with the negative A over B and the C over B. You don't have to know this, but I just think it's really nice to be able to understand why we're doing that. So if we have our original equation, AX plus BY equals C, and we want to get to slope-intercept form, we're going to rearrange our equation so that we have y equals something x plus something, right? So first we want to get our x on the other side of the equal sign, so we would subtract our x's, and that would leave us with, that would cancel. We would have by equals negative A x plus c. And we still have something being multiplied by y. We need y to be by itself, so we would divide by b on every term here. And my b's would cancel, so I would finally be left with y by itself equals negative a over b x. So that's our m. That's how we got that. Plus our little b, which ends up being c over b. You guys see that?
Yep.
I think it's kind of cool how we're able to do that. So yeah, that's where it comes from. Now that we know where it comes from, let's use those. I'm going to move that over just a little bit. So we just have to line up this original equation with our a, b, and c. So now we can use these values to find these values, m and b. So what is our a?
5.
5. So what am I going to put on top for my slope?
-5.
Good. -5. And what's b? 10. So I'll put 10 right here. And we can simplify this. What is the simplest form of -5 over 10?
-1 over 2.
Good. -1 over 2. So I've got a slope. Here we go. Let's write that in down here. My slope is -1 over 2. And let's find our y-intercept next. What's my c?
She's 30.
30. Good. And what's my b?
10.
10. Can we simplify? 3 over 1. What does that simplify to? 3. Our y-intercept is +3. What would that be as a coordinate?
That would be
0, 3. Yes, yes. Anytime we have a y-intercept, our x value is 0. We're just going up and down on the y-axis. We're not moving left to right on the x. Okay, so whenever we are graphing a line, once we have our y-intercept and our slope, what do we put on the graph first? Yes, the y-intercept at 0, 3. So I'm going to go over 0, up 1, 2, 3. Perfect. So there's my y-intercept. And where do I go from here?
down 1 over 2.
Yes, I want to use my rise over run. So I'm going to use these new pens. My rise is -1, so I go down 1. And my run is 2, the bottom of my slope. So I'll go over 2. Okay, and my second point is just right at the end of that run. That's it, 2, 2. Now we just connect the dots. Not so bad. I bet you this is all coming back to you guys now. Okay. And I would highly, highly, highly suggest that on this practice final, you write these little keys down. The m equals -a over b, and b, little b, equals c over big B. I would very highly recommend you write those, because on your final, you're going to have problems like this. And in case you forget, you'll have this to look back at and say, oh yeah, that's what I do. So write that. That way you have it. So you don't have to go digging through your notes for it.
Yeah, I got a lot of notes.
Yes, ma'am. Don't we all? All right. Any questions about this one? let's do number 5. Y equals 1/2 x plus 3. What do I do here?
0, 3.
Yeah, my y-intercept, it's already in slope-intercept form. So my b, or my y-intercept, that is 3. So Michael, you're exactly right. My coordinate would be 0, 3. So let's go ahead and put that on there. Over 0, up 1, 2, 3. And what's our slope?
1 over 2.
Good. 1 over 2. So how are we going to use our slope?
We're going to start with a 3, go up 1 over 2.
Yes. And thank you for saying we start from 3. I think it's super easy to forget that when we are making our second point, you start from the y-intercept. Do not go back down to 0. So we're going to go up 1 over 2. Oh, I did the wrong colors. There we go. And that's going to put our second point right over here at over 2, up 1, 2, 3, 4 at 2, 4. All right, and then we just connect the dots. And that's all. Okay, do we have any questions about either of these on page 2?
Yes.
Go ahead.
On our lines,
Mm-hmm.
do you still want us to write out the problems on the lines?
Ooh, that is a great question. So I know the first day that we started introducing like the systems of equations, I said that I really wanted you to label them so I could tell which is which. I would love for you to label your lines by writing, you know, the equation on there. So to label this one, I would do y equals 1/2 x plus 3. And for this top one, you would just write, you could either write the new slope-intercept form using the new slope and the y-intercept, or you could write 5x plus 10y equals 30.
Okay.
I'm not going to take points off if you don't label it, but if you do, it is nice because it helps just make your answer more clear so that I know that you're graphing the correct thing. I appreciate you asking that though.
Not a problem.
Okay, any other questions? Okay, can we go to the third page?
Go for it.
All right, page 3. Here's a throwback. Parallel lines and perpendicular lines. Oh my gosh, I forgot to draw the perpendicular sign. I left a blank space so I could draw it. I didn't. Well, if you want to draw that in, go ahead and give yourself a nice perpendicular line there. So let's look at number 6 first. The directions say to write the equation of each line described below and then graph your answer. So let's talk a little bit about what the steps are to writing an equation. Remember, there's 3 steps. You guys remember those 3 steps?
Yeah.
What are they?
Find m,
Uh-huh.
find y, and then write equation.
Yeah, so here I'm going to write these out to the side for you guys as a little review. So I'm going to write how to write an equation. And this is in y equals mx plus b in slope-intercept form. I'm not going to have you write any equations in standard form. So step 1 Michael, you said it perfectly. We're going to find m, or our slope. So we find m, and then second we find our y-intercept, or our b. Yeah, and you said it yourself, Star, and you just use those and put them in your equation. Write your equation, and that equation is going to look like this. Y equals, you're going to have some number here for slope m x plus, and then some number for b. Oh, that's going to be yellow. So the only numbers that you need are values for slope and values for y-intercept. Your x and your y stay x and y. Okay. So, what do we know about the slopes of parallel lines?
They're exactly the same.
They have the same slope. Parallel lines are lines that just go at the same angle. So if I have a line that goes like this, here, I wonder if I got a blank space to look at. If I have a line going like this, and let's say the slope is 1, if I wanted a line to be parallel to it, it would need to be at the exact same angle. It would need to be also having a slope of 1. So, for this problem, we are given that the equation we need to write is parallel to y equals 2x minus 3. So what value do we already know?
X and Y.
We do have an x and y that they give us. Say it again. We have a m. Now this is the b of the first line. This is our original equation. So we're going to have to find a new b. But because our new line is parallel, it's going to have the same slope. Same slope. So we have an m. We have our slope already. What's our slope? 2. So let's go ahead and circle that. Remember, we don't reuse our original b. And I'm going to write to the side m equals 2. And then Michael, you were a step ahead, but you're absolutely correct. We also have an x value and a y value that we can use. So we know that the new line is going to go through this point. It's going to go through x is 2 and y is 3. So how can we use this coordinate and this slope to find our new y-intercept? What can we do?
Plug it into the equation.
Yeah, we're trying to write a new equation in y equals mx plus b, so let's just plug in what we do have. We have a y, 3, equals mx. We have an m. It's 2. We have an x. What's our x? 2. Only thing we don't have is our b. So I'm going to write plus b. So once we plug all those values in to y equals mx plus b, you can see if we multiply 2 by 2 and then figure out the rest of this equation here, we're going to be able to solve for b really easily. So what is 2 times 2? 4. We want to bring everything down, so I've got 4 plus b equals 3. So 3 equals 4 plus b.
subtract 4 from 3?
Yes, I want to subtract 4 from both sides to get it to cancel out. Minus 4. So 3 minus 4, what is that? Negative 1. So we have a value for b now. b equals negative 1. So let's look back at our steps here. We needed to find slope, done. We needed to find the y-intercept, done. Now I just need to write the new equation. What is my new equation?
Y equals 2x minus 1.
Yes, yes. You're just going to put y equals, put your value for m, it's 2x, and our b was minus 1. And that is your equation. And here's something we can do to check, make sure it was right. Let's actually graph both of these equations. Let's graph the original and the new. So let's start with our original equation. Y equals 2x minus 3. What's our starting point?
0, negative 3.
0, negative 3. Good. 1, 2, 3. And where's our next point going to be? How do we find that?
Up 2 from negative 3.
Yeah, up 2 from negative 3. And then over how many?
1.
1. All right. Was that too fast? You guys want me to slow down a little? You remember this? Okay. All right, so let's connect the dots. This is our original line. So this would be a really great problem to label your lines on so that we can see which one is the original and which one is the new. There we go. So this is y equals 2x minus 3. And how are we going to graph our new line?
Start with 0, negative 1.
Perfect. Our y-intercept is negative 1. And what's next?
Up 2 over 1.
Up 2 over 1. Right there. And if we did it correctly, this new line should also go through the point I gave you. So over 2 up 3, looks like it does. Right here, yeah, there it is. So I could do that too. And let's connect the dots. And look at that, guys. That's a perfect parallel line. A little close together, but it's all right. And this one is going to be y equals 2x minus 1. Awesome. Okay, do we have any questions on number 6? Any at all? No questions, a bad question. We're feeling good? Okay, good. Good, good, good. Ready for number 7? Okay, number 7 is a little different because this time we're not drawing a parallel line. We're trying to find the perpendicular line. So what do you guys remember about perpendicular slopes? They do cross at a 90-degree angle. That is exactly right. They're going to be forming perfect 90-degree angles somewhere on this graph. How are we going to find the slope of our new line? Because it's different. Yes, yes. Oh my gosh, y'all rock. So this is called negative reciprocal. You guys remember that? Good. Negative reciprocal slopes. So all you do to find a negative reciprocal is you take your original slope. So negative 2 over 3. And remind me, guys, what am I going to do with that to make it the negative reciprocal?
3 over 2.
Yep, I'm going to flip them upside down and change the sign. So change it to negative 3 over 2, and then change it to positive 3 over 2. So there's my new slope. So that's step 1. We found our new slope. Okay, y'all ready for the next step?
Yep.
Okay, so let's use our new slope. And what else are we going to use to find our y-intercept? What do we do back here? Remember, we're trying to write an equation in y equals mx plus b.
Okay, we're going to take, okay, we already have the x and y.
Uh-huh.
Yeah, we're not going to do that.
So sometimes a great place to start is by labeling. I see I have a coordinate here, so I have an x. I have a y. And my slope here, 3 over 2, this is an m. So I have a y, an m, and an x. If I just plug those in, I can find my b. All right? So what am I going to write for y?
We're gonna write
3 equals, what's my m?
3 over 2.
Good. 3 over 2 times 3, that's my x,
Plus b.
plus b. Okay, now we can solve. So I need to do 3 halves times 3. What's that going to give me?
4.5, 4.5.
1.5? 4.5?
That's what I got.
Okay, perfect. That's what I got too. You guys all getting 4.5 for that? What'd you get? Okay, good. I thought you said that you weren't getting it. Okay, so 3 over 2 times 3, that is 4.5 plus b equals 3. Now what do I do?
Subtract 4.5.
Good. Subtract 4.5. Subtract 4.5. And what's that going to give us?
Negative 1.5.
Negative 1.5. That's going to be our b. Now, guys, I must not have worked this out good enough last night, because I swear I wasn't trying to give you a decimal for your b, because that does make it a little trickier to write the line. Because when you count your slope now, you're going to be counting half points. And on your actual final, you will not get decimals. I thought I made it on that way on here too, but I guess I didn't. So we have a b. We have an m. We have a b. What's our new equation?
Y equals 3 over 2x minus 1.5.
Y equals 3 over 2x minus 1.5. Okay, so let's graph these. Let's make sure we did it right. Let's graph our original line and our new line. Let's see if they make a perfect 90-degree angle. So our original line, where's our y-intercept?
1, 0, 1.
Yes, 0, 1. And we're going to use rise over run, negative 2 over 3 to find our next point. So down 2 over 3. Okay. And I'm going to connect my dots here. And again, guys, please stop me if I'm going too fast, or if you want me to repeat something or explain how I got something. I don't want you guys to feel lost. I don't want you to be left behind if I am going too quick. Okay, so that's our original line. Let's go ahead and label that. Y equals negative 2 over 3 x plus 1. Okay. And then let's graph our second line. Are you guys there yet?
I'm dead.
Okay. Anybody else still working on the first one? I'm happy to give you a second. Okay. So our new equation is y equals 3 over 2x minus 1.5. Where does our first point go?
1.5.
Yeah, it's going to be at negative 1.5. So right about here in between negative 1 and negative 2. Now here is where the not fun part is, because I don't know what I did here. Now we got to use our rise over run, but since we are starting at a half coordinate point, when we go up 1, up 2, up 3, we're counting in the middle of the tick marks now, okay? So our rise is 3. I'll go up 1, 2, 3. And our run is 2, 1, 2. Right here. So our next point is going to be at x is 2, y is 1.5. Just like that. I know, I'm sorry. I promise, I worked out the problem for your final and it's not a decimal. And then we draw the line and look at that. That looks pretty perpendicular to me.
That's almost a perfect death.
I know
Pretty
it.
good.
So there is that 90-degree angle. That's beautiful. We can label this one too. Y equals 3 over 2x minus 1.5. Awesome. And again, I love it when you guys do label your lines. However, if you forget on the final, I'm not going to take points off. You also don't have to graph the original lines. That's not in the directions. All I need you to do is to graph the new equation that you came up with. So you won't have points taken off if you don't graph those original ones. But sometimes it's just nice to check your answer, make sure you did it right. You can look at it visually. All right, any questions on page 3? Let's go to page 4. We're past the halfway point now, guys. Okay, so here are our linear inequalities. Now, Candy, I know you didn't get to be a part of learning about these, but they are very easy. I think everybody in here could probably tell you. They're super simple. I think you'll catch on right away. Yeah, they are kind of fun. They are kind of fun. Okay, so these are linear inequalities. So I need us to graph number 8. We've got 4x plus y is greater than negative 5. First of all, what form is this inequality in? Is it standard or slope-intercept? Standard. So we have two options. First of all, I know I've got an A, a B, and a C. I could manipulate those and do my negative A over B for slope and my C over B for my y-intercept. But I feel like this might be a case actually where rearranging the equation might be easier, and let me show you why. So watch what I do here. I've got 4x plus y, and I'm just going to say equals while we're doing this. 4x plus y is negative 5. Remember, y equals mx plus b is just a y by itself and then a number with an x plus another number. We already have y by itself. So if we just subtract 4x from both sides, get rid of the x's over here, then I would be left with y is greater than negative 4x minus 5. I'm in slope-intercept form now. I just had to do one little step. So if y is by itself already, sometimes it's a little easier to just subtract the x and get it on the other side. Now, if that whole process is confusing, just use negative a over b. That'll work just as good. Use that c over b. Do you guys want to do it the other way too? Just so you have it on here for your final. No response, but let's do it anyway. All right, so to find our slope, what is that formula using A, B, and C?
Negative A over B.
Good, negative A over B. And then to find our little b, or our y-intercept, what do we use?
C over B.
Good, C over B. So what is our slope gonna be?
4 over 1, negative 4 over 1.
Yep, it's going to be negative 4 over 1, which you see we got the same thing here, negative 4. And what about our b?
Negative 5 over 1.
Negative 5 over 1, or negative 5, which you see we got the same thing here by rearranging. So either way is going to give you the same answer. It's just thinking about what is the most efficient method. And again, if you decide to do it this way, you're going to get the right answer. So it doesn't really matter. Doesn't really matter. Okay, so now that we have a y-intercept and the slope, remember, graphing a linear inequality is the exact same thing as graphing an equation. The only thing that is different is the way that we shade our line or our graph. And let me pause this real quick. All right, so we have our points that we can graph. First of all, let's look at our symbol here. What symbol do we have in our inequality? Greater than. So are we going to have a solid line or a dotted line? Dotted. So I'm just going to make a little note, dotted line. And this is the optional part. If you have a dotted line, that means your points on your graph are going to be open circles. You're not going to color them in like regular points. I will not take points off your final if you do color them in, because we didn't go over that in depth. I'm just looking for your dotted line or your solid line. So let's graph this. Where do we start?
0, negative 5.
Yeah, our y-intercept is negative 5, so I'm going to go to 0, negative 1, 2, 3, 4, 5. Right there. And how do we find our next point?
Negative 4.
Oh my Lord, I didn't even give you room. Okay, well, 1, 2, 3, 4 over 1. So your next point goes off the graph. Sorry, guys. I swear, I thought I had these ready. It won't be like this on your final, I promise. Okay, now we just connect the dots. And when you connect your dots, don't forget to make it a dotted line. Once we've drawn our line, we can decide what direction to shade. There we go.
I love that. He was like so defeated.
I know, I swear.
Oh my God, it sure is not a Monday.
All right. Okay, so now that we have our dotted line, we've got our points, we just need to decide whether we shade above the line or below the line.
Yo.
So what's our symbol?
Greater than.
Greater than. So.
That's what I said above the line.
Yeah, I heard that.
I was thinking the fact that we're in the negative.
So now guys, I want to point something out. Sometimes when you have a really steep line, it's easy to mix up which direction is up and down. For some reason, the steep lines just mess us up. So a good way to remember is to go from one of your points on the line and look at straight up where that's going. And it shows that I'm going on to the right side of this line here. I'm going above. So we are going to color in this whole part above the line. And it doesn't have to be perfect. but feel free to make it as pretty as you want.
And don't pull a star. Just because it's in the negative does not say anything.
Yeah,
Dotty dot.
that's all right.
I'm a verb now, okay?
Candy, these making sense?
Yes.
Good, good.
So do we have to shade in color?
It doesn't have to be in color. You could totally, if you didn't want to shade it like that, you could even just scribble your pencil over it. Absolutely. It doesn't have to be fully shaded. It doesn't have to be in a color. I just like using colors. I just like to make it a little bit pretty. Okay, there we go. Close enough. So there is number 8. And when we get to number 9, this is the one where you might want 2 of those clear rulers rather than 1. So if you want to grab a second ruler, remember I got a whole bunch of them up here in the bin. It really does help to have more than 1 ruler on these problems. I think it does anyway. And you guys just let me know when you're ready for the second one.
I'm ready for number 9.
Awesome. All right, anybody else need more time? You guys ready? Okay, let's look at number 9. So this is the exact same thing, except for now you have 2 to graph on the same little coordinate plane over here. So system of inequalities, all that means is we are graphing 2 lines and we are going to figure out where the shading overlaps, and we're only going to color that part in. So let's just graph both of these lines and then we'll figure out the shading afterwards. So let's do the first one. I'm going to pick 2 different colors here. Do pink and purple. All right. What does my first linear inequality read as?
Y is less than or equal to
Mhm.
3x plus 2.
Perfect. Y is less than or equal to negative 3x plus 2. So am I going to have a solid line or a dotted line? Solid. So I'm just going to write next to it solid. And am I going to shade up or down? I've got Y is less than down. So I'm going to write solid and down, just so I have a little key next to it. And what about the second one? Is this dotted or solid? Dotted. Shade up or down? Down. Good. Okay, so let's go ahead and graph that first one. Where's my first point? 2 plus 2. And where will my second point be? How do I find it?
Negative side.
Okay, so my slope is negative 3. So where do I go?
Where we at here? First one?
Uh-huh. Negative 3. Remember, that's negative 3 over 1.
Down.
Rise over run. Yes, so I'm going to go down 3. So 1, 2, 3, and over 1. Okay, and this one is a solid line. So let's go ahead and draw that line. Make sure that we keep it solid. And we don't want to shade this yet. We want to wait until we draw both of them. You guys ready for the second one?
Yes, I'm ready.
Okay, I see people still writing. I'll wait a second. Take your time, guys. It's no rush. All right, let's do the second line now. Where's my starting point? Good, at -1. And how do I find my next point? Good, up 1, 2, over 1, right here. And these actually should be open circles, but even I just forgot, so it's fine. I'm not grading you on if you keep your circles open or closed. I'm just grading you on the line. What did we say this line was going to be, dotted or solid?
Dotted.
Dotted. So make sure you dash your line, dot your line. Okay, so here are our two linear inequalities graphed. And now we just need to decide where to shade it in. Yeah, so here's how we can decide using our rulers. First of all, I see that both of these are less than, so I'm going to put my ruler under this line and under this line. Wherever my rulers overlap, that's where you shade. So that's what the two rulers are for, just to be able to see the overlap. So as you can see, we're going to be shading that bottom triangle right there. That's where they overlap. Only shade that part. Does that make sense to everybody? Good, good, good. If you have any questions, feel free to ask.
So does it matter what color we're shading in?
Nope, does not matter. It can be either color, or it can be, if you're doing it in pencil, you can do it in pencil. I don't mind at all what color you use. It's a good question though. Okay, and that would be your answer for number 9. Ooh. Okay. Are we ready for the next page, or do we have any questions at all about these? Do we feel okay about them?
I'm good.
Okay, good. All right, page 5. Here we have the systems of equations, okay? So this is the same thing. You're just graphing these two and you're finding the intersection. So remember, what is the solution in a system of equations?
Where the two lines meet.
It's just where the two lines meet. Your answer is going to be a coordinate. There's 1 point. So in a system of inequalities, you see that there's shaded sections. That's our answer. In a system of equations, we're not shading anything. It's just going to be a point where they cross each other. Okay, so let's go ahead and do this by graphing first. So I've got y equals 4 over 3x minus 6, and then I have 4x plus 3y equals 6. What should I do here?
Start where you could either convert the second column or you start graphing the first column.
Yeah, absolutely. You could do either way. You could either go ahead and graph this first one, or you could convert the second one first. What do you guys want to do? You want to convert first, or just go ahead and graph?
Let's convert.
Yeah, let's convert first. So what form is my second equation in?
Standard.
Good, it's in standard form. So I have an A value, a B value, and a C value. So remember to find our slope and our y-intercept. We're going to use A, B, and C. Our slope is negative A over B. And our y-intercept is C over B. So what is our slope going to be? Perfect, negative 4 over 3. And what is our y-intercept going to be? Perfect. 6 over 3. Can we simplify? 2. Good. So now we have a slope and a y-intercept for our second equation. And now we can graph these. Which one do you guys want to start with?
Start with the top one.
Yeah, let's start with the top one. So where's my first point?
0, -6.
0, -6. 1, 2, 3, 4, 5, 6 right here. And how do I find my second point?
We're gonna go
Up 4.
Good, up 4 over 3. So 1, 2, 3, 4. And 1, 2, 3. There's my first line once I connect the dots. And since we're trying to find the intersection with our graph, you want to be as precise as possible so that where your lines cross is going to be accurate. So maybe even add a couple more slope points. So I know I'm going up 4 over 3. Let's go up 4 over 3 again. 1, 2, 3, 4 over 1, 2, 3. Your line's going to be more accurate the more points you've got on it. More things to line your ruler up with. Because these should give you nice whole number answers. But I've been wrong before. So we'll see. Okay, how do we graph our second line now?
uh, 0, 2.
Perfect. Our y-intercept is 2, so I'll go over 0 up 2 for my first point.
Down 4 over.
Yes. Down 1, 2, 3, 4 over 1, 2, 3. Ugh, look at that. Perfect intersection right there. So we're just going to connect the dots. And now that we've graphed our system of equations, what is our answer?
Three -2.
Yes, 3, -2. So whenever you answer number 10, please write your answer as a coordinate. 3, -2, and circle that. That's your answer. Good job. Any questions on that? Okay. Number 11 and 12, these are going to be bonus points. We didn't go over this much. So if you want to mark that on your paper, these are bonus. It's not going to hurt you if you get them wrong, but it will help you if you get them right. You can get up to 3 points for each of these. So that's 6 bonus points. Okay, anybody still need number 10? All right. Also, I'm looking at the time. It is 11:50. We've got 5 minutes until lunch. We are probably we're gonna have to come back after lunch just so we can finish this back page and these 2 problems. Would you guys rather take a break here and have a little bit of a longer lunch since we're coming back after anyway?
Sure.
Okay. Everybody good with that?
Yep.
All right. Let's go ahead and pause it here then. And I will see you guys back at 12:30. Okay, so we are back from lunch. And we are looking here at solving systems of equations. We're using the methods that I have given you. So we just solved this one by graphing. And now for number 11, we are going to solve using substitution. So we talked very briefly about substitution yesterday. We spent maybe 10 minutes on it. So we're going to go over it again today. Let me see. I want to find, there we go, a little piece of notebook paper. So I drew a little diagram for you to kind of show what we're doing when we are substituting. Basically, when we have two different equations that are both saying y equals something and y equals something, what we're going to do is we are going to substitute one of these values. So for example, I have y equals x minus 2. I could just put x minus 2 in for y on this equation because I know y is x minus 2. So then I would have an equation with x's in it, and I could solve for x. And once I've solved for x, I can plug that value into either of these and solve for y. So we're doing a whole lot of rearranging and stuff. So let's just walk through this process together. Like I said, I've got these written out. Basically what you're going to do is set negative 3x plus 2 equal to x minus 2. Who's confused? Anybody confused about it?
You can do either way, right? So
Yes, either way. Basically, to solve by substitution, you are either, I'll write out both ways, you can either do negative 3x plus 2 equals x minus 2, or you can do x minus 2 equals negative 3x plus 2. Both of these ways will work the same. Absolutely. So let's go ahead and do this first one. I've got negative 3x plus 2 equals x minus 2. So to solve an equation where we have variables on both sides of the equal sign, little throwback, what do we need to do first?
move the x over.
We need to get all our x's on the same side first. Then we can divide to separate. So if I were to try to get x by itself here, I cannot separate it from negative 3 yet. Because first of all, I still have a plus 2 over here, and I still have an x over here. First thing I want to do is get all my x's on one side and all my non-x's on the other side. So would you guys rather add 4 or subtract 1?
Subtract 1.
Subtract 1? Sure, let's do that. So minus x on both sides. And we can do that because these are like terms. If we have numbers that are attached to the same variable, we can combine them. So what is negative 3x minus x?
Negative 4.
Yeah, it's negative 4x. What would I do next?
So rewrite the rest of the equation.
Yeah, let's rewrite the rest. I've got plus 2 over here equals negative 2. And what do I do next?
Minus 2.
Yeah, perfect. So I'm going to subtract 2. Subtract 2. Those are going to cancel, and I'm left with negative 4x equals, what is negative 2 minus 2?
Negative 4.
Negative 4. And I'm down to my last step. What am I going to do to get x by itself?
Divide by negative.
Yes, divide by negative 4 to cancel those. Divide by negative 4. And that is going to give me, what is negative 4 divided by negative 4?
1.
Yeah, x equals 1.
That's why I got
Okay.
it the other way around.
Perfect, yeah, and if you do it this way, you'll get the exact same answer. It's just going to look slightly different in your steps. So there's our x value. And remember, when we are solving a system of equations, you're really just looking for the intersection of two lines. So we want to write our answer as a coordinate. So we have an x value. Say it again.
1, 0.
So we have 1, but we need to make sure that 0 is the correct y value. So I'll show you how we're going to do that next. We've got 1 for x. So now how could we find a y?
Just plug it in one of our previous equations.
Yeah, all we have to do is take the x we found and put it inside of one of these equations. Either one is going to work. Either one. Which one you guys want to do?
Go with the bottom one.
Yeah, let's do the bottom one because all we're going to have to do is 1 minus 2. So let's plug that in. I'm going to rewrite it over here. Y equals x, which is 1, minus 2. So what is y?
3.
1 minus 2.
Negative 1.
Negative 1. If I have 1 and I take away 2, yeah, I'm going to have negative 1 left. So we now have a value for x, which is 1. We have a value for y, which is negative 1. And that's our answer, 1, negative 1. Okay, now as we go through these problems, make a note for yourself somewhere if there's any of these that we want more practice with once we finished this. I'm happy to go through some more examples with you guys. Any questions about number 11?
Do you have to write down all of that, or do you just write down the solution?
No, you don't have to write all this work out.
Okay.
The only thing is, whenever you write your work out, if you make a mistake, I'm able to then look at it and see where you got your answer so I can give you partial credit.
All right.
So you don't have to write your work, but it's only going to help you if you do. Okay, any other questions? Okay, let's look at number 12. This is the second method of solving that we talked about. This is elimination. So I drew another little diagram for you here. This is usually done with equations in standard form. So we'll have ax plus by equals c, ax plus by equals c. So whenever we are using elimination, we are trying to get rid of our x values or our y's. We're just doing x for now though. So we need to get our x's to be the same number, but one is positive and one is negative. So what I showed here is if I multiply my bottom equation by negative the number of the x in the top, and I multiply the top equation by the number next to the x in the bottom, sounds confusing till we see it written out, then we're going to get the same numbers for our x values and they will cancel out. So let's look here. I've got 4x plus 3y equals 26, and I've got 5x minus 2y equals 12. What could we multiply these numbers by to get them to be the same?
4 and 5.
Yeah, let's just use 4 and 5, 5 and 4. So I'm going to multiply my top equation by 5, and my bottom equation by what?
4.
Negative 4.
Negative 4. If I do it by 4, I'll get 20x on the top and 20x on the bottom, and when I add them together, I'm going to have 40x. That does not eliminate my x. So I want to do it by a negative 4, so I'll have positive 20x and negative 20x, and they'll just cancel out. That's where the elimination part happens. Okay, so this is where we need to remember how to distribute, because I can't just times it by my x. I'm multiplying it by every term. Okay, so let's write our new equations down here. What is 5 times 4x? 20x. What is 5 times 3y? 15y. And what is 26 times 5?
130.
Yeah, 130. Okay, and now let's rewrite the second one. We're multiplying all the terms by negative 4. So what is negative 4 times 5x?
Negative 20.
Yes, negative 20x. What is negative 4 times negative 2y?
Negative 8.
We got a negative times a negative.
I got it. Positive 8.
Yeah, so plus 8y. And negative 4 times 12.
Negative 48.
Negative 48. Okay, so now that we have our distribution done, we have these two equations stacked up on top of each other, and we are going to just solve this like we are solving an addition or a subtraction problem. So what is 20x minus 20x? 0. So we got rid of x. What is 15y plus 8y?
23y.
23y. We'll bring down our equals. And then what is 130 minus 48?
82.
82. Okay. Yeah, now we need to divide by 23, and we're going to have a value for y. And what is it?
3.5.
3.5, that what we got? Everybody get 3.5?
Yeah.
82 divided by 23. Yeah, technically if we rounded it would be 3.6. You're right, Candy. Because here's what I got. 82 divided by 23. 3.56.
Yeah.
Remember, whatever number is next to it, yeah, if it's bigger than 5, we round up. So it'd be 3.6 if we were to round. However, I'm not grading you on rounding. And also, we're not going to have decimals on the final. So, I know. I'm sorry, guys.
Just like I'm not here.
Oh, man. So, let's be proper. Let's write 3.6 for y.
And circle it.
And circle it. Okay, now we have a y value. But remember, how do we write our answer for a system of equations? Yeah, we need an x and a y. It should be like a coordinate. So for our y, we can go ahead and write 3.6. And now we just need to solve for x. So how do we find x?
Put 3.6 in one of our equations.
Yeah, just put 3.6 into y for one of these equations. Do you guys care which one we do? What are we thinking, top or bottom?
Top.
Okay, let's do the top one. So I have 4x plus 3 times y, so 3.6. 4x plus 3y equals 26. Okay, so now we just need to solve for x. And you guys tell me what you get. Try to work that out all the way through.
10.8.
Oh, you're quick. Okay, 10.8 for this part. Good. Let me subtract 10.8 from both sides. Tell me if you guys get the same answer.
I did.
You did? Good. Okay. I wrote it down, but I'm not going to say it out loud in case you're still working. You can keep working. If you are done, look up and see if you got the same thing. Good, 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 good. Okay.
Pretty close.
I know, they really are. Okay, everybody get 3.8?
Yeah, 3.95.
3.95. Okay, walk me through all the
Oh, no,
steps you did.
No, I know what I did wrong.
Oh, okay. Okay, cool. Good, good, good. You tell me once you do get to that answer. And we'll move forward. Make sure everybody gets there first. I don't want to move on just yet.
Yeah, I got it.
Good. Any questions about this, guys? Good. I love that you love it. Okay, we ready to go to the last page? Let's do it. Okay, this is statistics stuff. Little throwback. Okay, so on the last page, you see we've got a set of data here. In the X column, we've got our temperatures. In the Y column, we've got some values for hot coffee sales. So we would read this as when it was 98 degrees outside, they sold $50 worth of coffee. 86, 65, keep going on, so on and so forth. So once you've kind of peeked around at this chart, I want to know what type of correlation is shown in the data set of temperature versus hot coffee sales. And then I want you to explain. What is that?
Negative.
Negative. So guys, remember, I'm going to write a little note out. Correlation, there's two types of correlations we can have. So whenever one variable increases at the same time that another variable increases, so maybe that would mean when the temperature rises, the sales get more money, this would be a positive correlation. And the exact opposite is true for a negative correlation. So we can see here, as the temperature gets lower, the coffee sales get higher. So whenever the variables move in opposite directions, that's a negative correlation. So good. So for your answer here, I would say negative correlation. Because as the temperature decreases, sales increase, or something along those lines. Now remember, just because we got a negative correlation for number 13 on the practice final does not mean that it will for sure also be a negative correlation on the actual final. So make sure you do understand the difference and you can explain both, just in case, because I don't remember which one I put on there. I just don't want, we don't just copy and paste our answers, because as the temperature decreases, hot coffee sales increase. All right. So there's number 13. Any questions about number 13?
I put negative correlation. As the temperatures decrease, the sales increase.
Perfect. That's a perfect explanation. Okay. Ready for 14? Okay. So in number 14 it says, a researcher noticed that when hot coffee sales decrease, there is a noticeable increase in the number of people swimming in the neighborhood swimming pool. Is this an example of causation or correlation? Explain your answer. Now, before we explain this one, what is the difference between causation and correlation? You guys remember?
Causation is something that the two that went together that caused something to happen.
Yeah.
Directly
Yes,
affects everything.
exactly. So whenever we have causation between two variables, that would mean that those variables directly affect each other. So one of those examples was how much you water a plant. Basically, the more you water it, assuming that water is good for the plant, this won't go for all plants, but assuming water is good, the more you water it, the more it grows. The less you water it, the less it grows. There's causation there, because if you take the water away, it's going to change it. If you add water, it changes it. Something like this. Is this causation?
No,
Why not?
because it's nothing that links the two of them together.
Right. So just because we sell less coffee, that's not going to cause people to swim more. They just so happen to move in that similar way. because there's probably something affecting them both separately, like the weather. Okay, so what would we write as our answer here? I asked, is this an example of causation or correlation? And then I want you to explain.
I wrote correlation. There is no evidence that one directly affects the other.
That's a perfect answer. Correlation. I would see, you could say all sorts of things. Your explanation was perfect, Michael. I'm going to say these variables don't cause each other to change. Or you could say these two situations have nothing to do with each other. You could say they don't directly affect each other. There's a lot of answers that I would accept. Okie dokie. Any questions about number 14? Okay, number 15. Last question. This is where we draw a box and whisker plot. Before we draw this, let's go through a little guide of how we do that, just in case we forgot. You should have a guide in your notes. If not, here we're going to make a little baby guide. So, a box and whisker plot. First of all, it looks something like this. You're going to have 5 different values that are important here. Do you guys remember what those values are?
R,
Q1,
Q2, Q3.
Uh-huh. So the first number is the minimum value. So the smallest number in the data set. The end of our graph here, our box and whisker plot, is the maximum value, or the largest number in our data set. And then you guys said Q1, Q2, and Q3. What'd you say, Star?
Q2 is our mundane, our middle point.
Ooh, say that word again.
The mundane.
Almost.
Middle point,
Median.
median.
Very close. Median. Yes,
There it
yes.
is, median.
Okay, so let's also talk about how we find Q1, Q2, and Q3. So whenever we have data values, let me give you just an example set of data. We'll do the real one here in a second. Let's say I have 3, 4, 7, 8, 12, 15, 20. Let's say this is our data set. So first of all, what's our minimum?
50. Oh, I'm sorry.
Whoa. I'm like, man, what's the minimum of this little data set I gave you? 3. That would be our minimum. What's our max?
20.
20. That's our maximum. And I always like to start by finding Q2 first. That's going to be our median.
Median.
So remember, the median is just the number in the middle. We're not having to do a whole lot of math there. It's just the number that's in the middle. So let's walk through how we find that again. I'll wait for everybody to get caught up. So if you don't remember how to do median, look up here real quick. This is all we're going to do. I'm going to cross off numbers in pairs at a time. 3 and 20, 4 and 15, 7 and 12, and 8's in the middle. So Q2 is 8. So Q2 is 8. So we're going to draw a line in between 8 right there so that we know when we find Q1 and Q3, we're finding the median again, but we don't include Q2. We don't include the number 8 there. So that's why I'm drawing a line through it. So to find Q1, I need to find the middle number of these 3, which is 4. So my Q1 is 4. And my Q3 is, yeah, 15. Q3, 15. Okay, so now that we have our numbers, we can put them on the graph. I go from 3 to 20. Let's see. 0, 5, 10, 15, 20. All right, not perfect, but you get the idea. You want each of your values to line up with the box and whisker plot that you draw. So our minimum value was what? 3. So at about 1, 2, 3, 4, 5. So about here, this is about 3. This is where we would draw the end of our box and whisker plot right there. Where was Q1? 4. So it's really close together. 4 is where we would put the edge of our box, and you see there's that whisker. See that? Where's Q2?
Q2 is 8.
8. So 5, 6, 7, 8, 9. There's 8. I'm going to draw my middle line of my box. And where's Q3? 15. So that's where I draw the other end of my box. And what's my max? 20. So I want my other whisker to line up with 20. Okay. So that's a quick little example, just to get our brains going back into that direction. Let's do number 15 now. You guys ready for that? Okay. So, number 15, I want you to draw a box and whisker plot using the data values in the hot coffee sales column. So, one of the first things that we might want to do is maybe just rewrite these numbers down here. So, we want to be really careful. Don't miss any of your data values, any of your the data values. So, I want to rewrite them all in order. 50, 65, 69, 78, 83, 98, 125, 142, 173, and 207. Perfect. Okay. So, oh my goodness. Here's our data. What should we do first?
Min-max.
Yeah, let's find our minimum and our maximum. What's our minimum? 50. So we could go ahead and mark 50 on our number line. And we could even start our whisker if we wanted to. What's our max?
207.
207. So I'm going to mark 207 on my number line. There's 205, about here-ish. So that's where my box and whisker plot is going to end. Here's my 2 ends. And what should we do next?
Find our median.
Yeah, let's find our median, or our Q2, the middle of our box and whisker plot.
That's where I'm having my problem.
Yeah?
83 plus 98.
How so?
Oh.
What are you having a problem with?
I didn't think we added the 2 together.
Well, let's see.
Yeah.
Is
There's not one in the middle. It's not.
Okay, yeah, because I just.
Let's review this. Okay, so I don't want to draw all over mine. So 1,
Divide by 2.
2,
That's
3, 4. Okay, so we've got 83 and 98. We don't have a number in the middle here. So let's draw a line right there in between 83 and 98. There's a couple of ways that we could find the number in the middle. So first of all, you could write out all the numbers in between and find the median of that. You know, you could look here and say, here's 83, here's 98. It's going to be somewhere in the middle of there. But if you want to be the most precise and do it in the least amount of time, we're going to add our two middle values together and divide by 2. So 83 plus 98 divide by 2. And you guys tell me what you get for that.
I got 90.5.
Okay, divide by 2. Say that one more time.
90.5.
90.5. All right. You guys are getting the same thing, I hope? Let me know if you get something different.
All did.
Good. 90.5. So we are going to find about 90.5. Now guys, this is something that a few of us messed up on last time. Whenever we have 0.5, that doesn't mean it's 95. If you put your point in between 90 and 100, you will be wrong. It's just a tiny bit past 90. Yes, you did, girl. That's okay. That's okay. Hey, you know what? I love it. You admit your mistakes, and you will never make that mistake again.
But if you notice, I had it wrote down.
You did. You had it written down right. Silly, silly, silly. So this is our Q2. It's the middle of our box. We could go ahead and draw that line if we wanted to. And now since we didn't have a number in the middle here, we don't have to exclude anything whenever we find the Q1 and Q3, the medians here. So what is Q1 going to be? 69. Good. So let's go ahead and mark, it's about 69, right under 70. So there is the other end. Now I can connect this. And what's going to be my Q3?
142.
Yeah, 142. Okay, and I'm going to label all these. You guys might want to also, just for reference on your final. So your min and your max. 69 was our Q1, 90.5 was our Q2, 142 was our Q3. So 142 is a little above 140, about right there. And now I can connect my whiskers, and don't forget to close your box with lines on the top and bottom. If you just keep lines, it won't be correct. Gotta draw the actual box and whiskers. I know. I know. So mean. It's so terrible of me to give you a practice final.
So that long whisper on the other end, I get a match. Those are outliers, right?
Yes. So it's not necessarily that they're outliers because, okay, so I say yes quickly because in most data sets that would absolutely be an outlier. However, in this case, I'm going to say it's not an outlier because it is relevant. They're obviously making way more money once it hits like the 60s and the 50s. And up here where the temperature is much higher, they don't make as much money. And that makes sense since they're selling hot coffee. So what this is showing is they're making most of their money in this value here. Now obviously we aren't comparing this also to the temperature. This is just the money they made. But we had most of our data in these smaller numbers where they made less money. So that's why it's showing most of our data is on the smaller end of the graph here. And there was only a couple of days where they made over $140. So that's why we have such a long whisker over here. Does that make sense? Okay, awesome. Yeah, so if you wanted to, this is another way just to look at it. I'm not testing you on this, just a little FYI if you're interested. Basically what we found here is where each fourth of the data falls. So 1/4 of my data points were between 50 and 70. 1/4 of my data points were between 70 and, or well, about 69 and 90.5. Another 1/4 or 25% of my data was between 90.5 and 142. And the other fourth was between the last two values. So it's just showing you another way to look at the spread of data and where it falls on that chart. Any questions? That's it. That's your final.
I do have a note about the data sets that might be
Sure.
useful.
Yeah.
If your data set is even, your median, you're gonna have to figure out by adding the two middle numbers.
Yes.
But if it's odd, you're gonna have a perfect middle.
That's right. So absolutely, Jeremiah, you are 100% correct. When we have an even number of data values, then when we cross them off and get to the middle, we're not going to have a number in the middle. When we have an odd number, like, let's start with a small one. If we have 5, when I cross off these two and these two, I do have one in the middle. Or if I had 7, I've got 2 more on the side and 1 in the middle. But if I have an even number, there's always going to be a split. See that? Yeah, thanks for pointing that out. That is helpful. Okay, guys. That is all. Our final is tomorrow. If any of you are wanting to take it today in the next 40 minutes, you can. However, just because we don't have a huge chunk of time, I wouldn't suggest it unless you're just like a super speedy test taker. I'm going to end that recording there, and if we have any questions, we'll keep going. So I'm going to just